I did the answers to questions 1 to 6, and I uploaded that video, and it's called something like Sine and Cosine Part 1. So I'm only going to continue from number 7. So between the two videos, you'll have every single question answered, and you can see how any of them is done. Okay? So I really want you to watch the video later today from the 9 o'clock class. Okay? Because you really need to see how to do 1 to 6, because I'm sure nobody got 1 to 6 perfect. Not even me, because my answer for number 5 is wrong. I think, yeah, but it's not the answer to that, right? Like, what answer did you get?
I answered from 1 to 4. Yeah, not exact.
Yeah, so did I, but not 6-3.
Yeah.
I think it's like 6-8? 6-6?
Yeah.
6-6? Yeah. Anyways, let's continue from number 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want to see 12 YouTube views later, okay? When I go to my YouTube channel, I want to see that the video is viewed 12 times. So I know that you all viewed it, okay? I'll count. I'll check later. Right, number 7. A telephone pole has 2 wires attached to it. Each wire is connected to a peg in the ground and to the top of the pole. The first wire is 15 and makes an angle of 53.1, and the second is 13 and makes an angle of 67. What is the minimum distance between them? So what I'm testing in this question is, can you draw the picture, really? So there's the ground, there's the pole. There's one wire like this, and this angle is 67.4. and 13 meters. But then there's another wire like, oh flip, I drew that wrong, sorry. What's the first one? 53.1. And what's the length? 15. And then the second one is shorter, it's 13 meters, and this angle here is 67.4. And I want to know what is the distance here. Okay? Okay? So look, if you look at this triangle, this big one here, it's right angle triangle, we have enough information to get the base. I'll call the base B. You could say cos 53.1 equals B over 15. So you could end up saying then that B is 15 cos 53.1 for the total distance here. And if I call this smaller distance, let's call it small b, then in a similar way you can get small b is 13 cos 67.4. And so the answer will just be the difference between the two. So if I call that distance here delta, then the distance we want will just be the difference between these two. So let's calculate the difference. So the bigger one minus the smaller one. 15 cos 53.1 minus 13 cos 67.4. So that's 4.01 meters. Now, in part 2 of the question, the only difference is I want the maximum distance, which means that this peg is over on the right. Same angles though. Yeah, same angles. So in part 2, all I have is this picture, where this is 15 and this is 13, and this is still 53 and this is still 64. And the only difference is the two bases, instead of minusing them, you add them. That's all. So that's for part 1. Part 2, we'll just add the two bases together instead of minusing them, and we'll get 10.2 meters instead. What the heck? That's not right. I got 14. Did I make a mistake? Oh, yeah, sorry, I lost a number here. 13, not 3. 14, yeah, 14. You wrote this down? Will we continue with the next part? Yeah. So, number 8 now. Oh, I have to draw this in 3 dimensions, which I don't like. Ugh. Three superheroes are trying to stop a helicopter flying away. A is at 19 from B, B is 17 from C. So you've got 3 of them on the ground. A, B, and C. And you know the distance between A and B is 19. And B and C is 17. And you don't know the distance between A and C, right? Each of them has a 26-meter rope, and they're holding the helicopter in place. And the helicopter is 24 meters above the ground. So up here, a distance of 24 meters from the ground is the helicopter. And each of them has a rope of 26 length, holding the helicopter in place. Interesting, right? So, let's do this one. It will require many steps. Can you all picture the story?
24.
The rope is 26, but the helicopter is a height of 24 from the ground, right? Yeah. Now, you need a bit of imagination here. So what we'll do is we imagine there's a right angle triangle here. Can you see that? If you look at this triangle, we know its hypotenuse is 26, that's the rope. Its height is what? 24. So Pythagoras can give us the base. Is it 10? 26 squared minus 24 squared is 10. Should I trust you? Okay. But if I get the wrong answer, then I'll never trust you again. Okay, 10. So, if you draw another right angle triangle here, you get 10 on the ground as well, because the information is the same. And if you draw another triangle here, you also get 10 on the ground, because the hypotenuse is 24, the hypotenuse is 26, and the helicopter is 24, the height is 24.
So it's like 2 isosceles triangles?
Yeah, it's like 3 identical right angle triangles. Now, what I'm going to do next is I'm going to look down at the situation from above. So if I look from the sky, I can see this picture. There's a helicopter in the middle of the 3 of them, and this is 19, and this is 17, and this is A, and this is B, and this is C. And there's a rope here, there's a rope here, and there's a rope here. Now from the sky, how long are these 3 lines?
10.
Yeah, they're each 10 because they represent these 3 bases. So that's a 10, that's a 10, and that's a 10. Now the situation is much improved because we have quite a lot of information here. We're just looking for this side. Okay? So what I'll do is this. I'll get this angle. Then I'll get this angle. If I have these 2 angles, then I know this angle. If I know this angle and this side, I can finally know this side. So let's get our angles. Let's call this angle alpha, and this angle beta, and this angle gamma. So what will give me alpha? The cosine rule. Yeah. So I can say 19 squared equals 10 squared plus 10 squared minus twice tan cos alpha. Is that okay? Shall we get the alpha here? Let's calculate that. 19 squared minus 10 squared minus 10 squared divided by minus 200. So if you rearrange this, you get cos alpha equals minus 161 over 200. And then cos inverse, yeah, which I'll do it now. The heck is with my pen? Changed it. Alpha equals, so if we do shift cos inverse answer, we get it. You're in radian mode, aren't you? Yeah. Now, let's use our store function. Where's it gone? Where's store? Right. Shift store as A. Alright, so alpha is now stored as A on my calculator. Right, let's do the same thing and get the beta. So I can say 17 squared equals 10 squared plus 10 squared minus twice. Nearly the same thing, isn't it? The only difference is 17 instead of a 19. So let's see. 17 squared minus 10 squared minus 10 squared divided by minus 200. So cos beta is minus 89 over 200. So that means beta is cos inverse of that. 11642. I don't need to worry because again I'll just store this on my calculator. Shift store as B. Super. Right, so now we are finally able to get the gamma angle. How can we get the gamma? The gamma will be 360 minus minus alpha minus beta, because the total has to be 360 in the center. So 360 minus alpha minus beta 99.96. Let's store this as C. Okay, finally we can get this missing side, we'll call it x. I shall use the cosine rule once again. So x squared equals 10 squared plus 10 squared minus twice tan cos gamma. So square root 10 squared plus 10 squared minus twice tan cos C. 15.3 meters is the answer. 15.3 meters. Oh, to the nearest meter. To the nearest meter, 15.
So you basically found the base, yeah? That's the last part?
Yeah, the last part is I finally got the distance between A and C, which I called x. Go ahead.
I only have an issue with one part, which is I don't understand the thought process in my thinking of a circle. Like I don't see how, and then I'll think about it. Like I don't see how you
So your question is really, teacher, make me smarter?
No, I don't see how you reach
Yeah, I get this all the time. I'm sorry to tell you, there's no secret. It just comes from a sheer stupid amount of practice, different types of problem. You know what I mean? I get this question all the time in physics. Students ask me, but how did you know to do that? And I said, I'm sorry, it's just, after you do 1,000 questions, you just know inside,
Sir, we haven't talked about the circle rule, like the triangle.
Yeah, we don't.
So, we're not going to talk about that here.
No, no. What you could do is look at one of the books I uploaded on Moodle, and you could practice more practical problems from one of the books. You see, the only reason I knew how to do this one, and I made this one, is because I saw something similar to it in another book, Like, the first time I would have seen this question, it would have required me to do a lot of thinking about how to solve it. It wouldn't have seemed obvious to me that I had to then, in the middle, look from the top. So it only comes from practice. That's all, I'm afraid. Yeah. Okay. The good news is they don't really ask these three-dimensional problems in the exam. They try to keep it two-dimensional, not three-dimensional. I don't think I've seen a three-dimensional one in the exam, actually. Okay, let's have a look at the next one now. A plane leaves a point X heading east. Oh, and in the last class there was a bit of confusion. So look, north, south, east and west. Okay? Santa Claus, Mecca, penguins, America. Alright? Don't forget, please. Okay, so 9. A plane leaves point X heading east. Off it goes. Another plane at the same time leads Y at the same speed. The point Y is 20 degrees north of east from X. So 20 degrees, so the Y is like over here. This is Y, and it's 20 degrees. So if I draw a line here, it's 20 degrees here. Okay. And I want to know what angle should this plane head at so that it will meet with this plane. Now, let me just draw these arrows a little bit smaller. They're a bit big. Right, there's Y. So X heads to the east. Y heads at some angle here. You want to figure out the angle. You want them to meet. Some point here. Okay.
Angle of Y?
Yeah, you want to know what direction the Y should head at. So, you could figure it out, like, you could say what this angle is, if you like. You could say how far south it should head. So, we'll try and figure out this angle. We'll call it theta. And this angle here we know is 20.
Where do you find the angle inside?
Oh, that's fine too. That's fine too. Doesn't matter. Once you make it clear in your answer, which angle you're given. Okay. This one's quite hard. But it seems like you have not enough information here. In this picture you know literally only one thing, the angle. You have no distances. So it might seem like it's quite impossible, or so it would seem. There was one piece of information that I didn't draw in this picture, which I gave to you, which is vital. I said the planes are heading at the same speed. And of course I don't know if I said it, but I meant it anyways. They leave their airports at the same time. Yeah, but why? Well, which is not necessarily 20. No. Okay, so listen carefully. There's a bit of logic going on here.
Meaning the base and the height is base and the other,
This one up here,
yeah, up here and down is equal. Right?
these are equal.
No. The line above y and the line on the x line, the east line should be equal, right?
Oh, so like this distance?
Yeah.
If I draw a straight line here? No.
Yeah, the top line and the bottom line.
You think they should be equal?
These ones and this one.
Yeah.
You're not quite right, but you are thinking
Parallel.
along the right lines.
You can draw a parallelogram.
Parallelogram?
Yeah.
Maybe. I'll tell you what I'll do. So listen, they won't leave at the same time, and of course if they meet, they'll meet at the same time, right? It's not like one will meet and then a minute later it will meet, like this is, they meet at the same time, okay? If they're travelling at the same speed for the same time, then they've travelled the same distance. So that means that this distance is the same as this distance, which makes it an isosceles triangle. Now, I drew it quite badly, but because they're the same distance, it means it's isosceles.
Then the angles are.
Then this angle is the same.
So under those part.
But I thought you were saying this angle. This is 20 as well. Now, we still have to figure out this angle. Yeah? That picture is terrible. Sorry.
Why? 180 minus 40.
I need to draw this again a little bit better. Okay. Sorry, let me just draw this a little bit nicer. That's why. Okay, so it moves along here, and this one, I think I have it drawn out too far. I think it's more like it must head a little bit to the left and meet here. Like, I don't know what angle it heads at, so when I drew my picture at the beginning, I drew it heading out here, but I think it's more like it heads this way. So the plane comes along, this one comes along, and they meet here. It just makes my picture look a little bit nicer because we said that they both travel the same distance, so it's isosceles, so it means these angles must be the same. Okay, so they're both 20. Okay. So you might say, oh, we're done, heads at 20. Well, no, not quite, because if I draw my axis here, east, west, north and south, you don't say the plane heads at 20, you still need to figure out this angle and then add the two angles together. Okay, so now our next job is to figure out what this angle is. Well, maybe somebody can spot what it is.
And find the biggest angle and use 180 degrees to understand.
You could, yeah. But I think somebody maybe can see a quick.
You want to do the cosine?
Yeah, well, this one is the same as this one. It's 20 because of the z, yeah. So if this is 20 and this is 20, because it's parallel, yeah, the total is 40. So it heads west 40 degrees to the south. That's the angle it heads at. West 40 south. Yeah? You like it?
I haven't found enough.
23. Don't worry, they'll never give you this in the exam. At least I hope not.
How did you do the duration?
How did I what? Oh, this last part?
No.
Yeah.
Yeah.
The way it works is you say what you start at. So you start at west, and then you give the angle, and you say which direction. So the angle to the south. So it's west 40 to the south. Yeah? No? Yes? No?
Wouldn't it need to go south?
What do you mean?
Because it's like above, right?
Well, you could also give the answer south 50
Yeah.
west.
Yeah.
That's the same thing. South 50 to the west. Many flexibility. If you're not confident, just draw the answer, you know. Here it is. It has to head this way, where this angle here is 40.
That angle.
Yeah?
The way point Y is 20 north of east.
North of east. Yeah, what does that mean? So that means you start at east and you measure to the north 20. You're not familiar with this? Okay, let me help you. Right, so if I say theta degrees north of east, what that means is you start at east, you start at this guy, and you measure theta degrees towards the north. Okay? That's the same as writing east theta degrees north. They're the same thing.
So before you can do it 50 south east. 40
You
south,
could say, yes, you could say 40
south east.
south of east.
Yeah, that's what I was.
Yeah, you can say it that way.
Can you go back to the previous?
The picture?
Okay.
So you could, yeah, so you could have said also 40 south, or not east, sorry, I meant to say 40 south of west.
That's the thing.
Yeah, yeah, yeah. Yeah, these are all the same thing.
So,
I'm giving you new vocabulary, or new grammar, is it? Yeah.
Question about the English.
Yeah.
Is the something north of east the same as something north to the east?
Ooh, that's a good one. Let me write that down. Say that again. So your first one was something,
Is something
no,
great.
something north of east?
North of east.
Something north of east. I don't think you would say north of east. You could say something northeast.
But where is the expression in your question?
Which question?
Question one.
Yeah, well, where do I say it?
Point Y is 20 degrees.
Yeah, you can say north of east if you provide an angle. So you could say some. Where's my pen? You could say something angle north of east. You have to include the angle. In other words, if you're using the expression north of east, you must have an angle. Because what north of east means is you're measuring an angle north of the east line.
45 degrees into
If you want 45 degrees, you can just say something
northeast.
northeast. Yeah. Yeah.
My question is the same thing as the north to east.
North to east.
Yeah, that's my question.
Can you give me the sentence, north to east? What would you say? See, I'm not sure. 20 north to east? I don't think you can say north to east. I think this is the wrong word. You can say north
would be after,
north of east.
Yeah, it would be after traveling east. You can say north to east, meaning you go like this and then this. Yeah.
No, then east.
Thank you. Thank you. Yes, north then east. Yeah. Amjet's English is spectacular. You're right, yeah. North then east. Yeah, yeah, yeah. I'm trying to think, is there a situation where you could say north to east? You don't really say northeast. You could say, you could if you say from. You could say from north to east. But if you say from north to east, what you're describing is all of this. From north to east means like that whole thing, yeah. It's like the whole region, you know. Yeah. Okay, we're back to this.
Yeah, no.
This.
Yeah, this one.
Okay.
Can we say 50 west of south?
50, you could say 50 west of south. West of south. Yes, you could. You could say that, yeah.
So that's another one.
That's another way to say it. Yeah. Okay, I think we've talked enough about north, south, east, and west. We can go on to number 10 now. Okay. Number 10's hard. 10. What is the radius of the biggest circle that can be put into a triangle with sides 13, 14, 15? Now, I would like to know if that triangle's right angle. I don't think it is. Does 13 squared plus 14 squared equal 15 squared? I don't think so. No, so it's not right angle. That's good to know. So you have a circle inside of a triangle. 13, 14, 15. And it's a big circle. Oh my, that's a circle. Now, I tell you that the circle is actually called an incircle. And what's special about this incircle is that it's at the intersection of the bisectors of the angle. What the heck does that mean? It means that if you cut the angles in half, so like if you draw a line here, where you cut this in half, you draw a line here, I'll put open circles here, that's in half, and if you draw a line here, we'll put X's then. We'll put X's then. These are the same. Yeah? So what am I asking you for? What's the radius? Okay, so I'm looking for this here. Radius, radius, radius. Yeah? So I think what we could do first is we could get some of the angles.
Right angle.
We could make right angle triangles as well. Cosine rule, I think, is what we need. Yeah, I need one of the angles. So I could get this angle here and then divide by 2. Let's see. Yeah? Cosine rule will do it. So I'll call the big angle alpha. So I can say 15 squared equals... you're thinking of the last question. 14 squared plus 13 squared minus 2 times 13, 14 cos alpha. Yeah? So, let's see. 15 squared minus 14... minus 14 squared minus 13 squared divided by minus 2 times 13 times 14. That's cos alpha.
No, wait, it's plus 13.
What? Did I make a mistake? What's my mistake?
Plus 13.
Is it? Because I'm dividing by minus.
I see you did.
I think I'm right. Would you agree or not?
Wait.
It's the same anyway.
Yeah? Okay. I can work out this angle. But do I have enough info yet? I don't. I need more info. Let's get all the angles. So, shift cos inverse my answer. That's what? I didn't press cos inverse. Can I go back? Shift cos inverse 5 over 13. 67. Right. I'm going to save that as A. That's my alpha. Right. Let me do the same thing for the other two. Now, you realise this is kind of like the previous question as well. So for the other angles, if I call this one here beta, I can say 14 squared equals 15 squared plus 13 squared, isn't it? Minus 2, 13, 15 cos beta. So I can get cos beta equals 14 squared minus 15 squared minus 13 squared divided by minus 2 times 13 times 15. 33 over 65. So let me save that angle. Shift cos inverse my answer. That's 59 degrees. I'll store that into B. Now, what's the easy way to get the last angle here, gamma?
180, 180.
Yeah, so if I just do 180 minus A minus B, that gives me C, my gamma. So I'll just store that as gamma, C. Right, so good news is I now have figured out alpha, beta, and gamma. Let me write them down. Alpha, beta, and gamma. So alpha, we said is 67.38. Beta, 59.49. And gamma, 53.13. Right. Great. So now what I can do, I can get these small angles. Divide by 2. So, can you see what symbol this is? I'll give it a letter. I'll call it A. So this here is an A. This small angle here is B. And this small angle here is C. So you know that small a is just half of this. It's just half of it. It's because the total here is 67. So let me get that on the calculator. You have it already? No, Stephen. 33.69. You can do the same for B and C. Wait, I just want to store this back into A. Okay, next one. B divided by 2 is 29. Let me store that again. Right, and the last one, 26.56. And then let me store that. Right, okay, so look, I know it's quite long, but let's recap what we figured out. We know this side, 14, 13, 15, and we know all of these angles. We know A, we know B, B, and we know C and C here. So what's left to do? The last thing is to get the radius, which we can just draw here. Right, so if we look at this triangle, we know C. What else do we know?
You know the angle.
We know the angle, yeah.
It's 90 and... Is it 90 degrees?
Flip, I'm still not even done. I know I have to get, the next thing for me to do after I got these is to get one of these lengths.
Well, what's the angle?
No, I think the sine rule. Say again? This here? Oh, like if I draw this here? No, I don't necessarily think this is equal. Yeah, if this was equal, our life would be much easier. I don't think so. I need to get this length. How can I do that? Oh yeah, I can use the sine rule. Do we know this angle?
Yes.
We do.
We don't know A and
What will we call it? Let's call it x. So x is 180 minus A minus C. Good grief. 180 minus A minus C. 119.74. Right. Let's store that as... Oh, I have an x. Wonderful. I have an x. Okay. Right. Sine rule. What will I call this side? D. No. S. Okay, so I can say S over sine A equals X over sine, 14 over sine X. So now I have S equals 14 sine 33.69 over sine 119.74 equals, right, let's get this now, 14 sine A over sine X.
Half sine.
Yeah?
We have the sine A, right?
Oh yeah, we do, we have the A. 8.94. Oh, do you know what? I should call that not X, I should call it Y. That would be better. Because I can store a Y on my calculator. Right. Shift, store, Y. Okay. Yeah, now we know this side. And we know this angle. And I can finally get this height. I'll call OR. Yeah. So, sine C equals OR over Y. Yeah?
Yeah.
This is Y. This side here is Y.
Yeah, that's how you get
Opposite over hypotenuse. So I can say now the radius is Y sine C. It's nice when a long question works out in the end with the right answer. So the answer is 4 centimeters. Oh, that was a nightmare. No wonder I made it the last question. Congratulations! 1,000,000 points for you if you got this correct.
They won't give us questions like this in the exam. It's too long.
Only in your worst nightmares.
Oh my god.
They won't. They couldn't. It would be ridiculous. It'd be ridiculous. We can do other questions now. Yeah. From probably let me guess, the area one, is it?
Yeah, we have okay, for the
Hold on, which page are we looking at?
58.
Yeah, which one?
You know the ones where we have to prove the area for
Yeah.
the equilateral isosceles? I did it to Pythagoras when I found it another way which also works.
Good for you.
Yeah, but like how do I put it in that form? I don't know.
I don't know what you're asking me.
Like you know how we have to use Pythagoras to find the area on these. When I did use Pythagoras, like for example the isosceles one, instead of getting this negative 1 over 4, I got A area is equal to A over 4 radical 4b squared minus a squared.
It's possible to rearrange it into that. Let's see.
But that's what I got first.
Okay, well let's see. So if we go to page 58, what question number? 7. Now, yep. Guys, listen. Are we listening? So, Mo here tried number 7 and he got an answer which is not sure if it's the same answer. I want to see if his answer can be rewritten into the answer in the book here. So what answer did you get?
A over 4.
A over 4.
Radical.
Root A over 4.
No.
Oh, like this, yeah.
4b squared minus a squared.
Right. Let's see if we can rewrite his answer into the one in the book. Yeah, so you can change this into A over 4 root, we can take out the 4, b squared minus a squared over 4. Is that okay so far?
Yeah.
Are you sure?
Yes.
So, what I'll do next is I'll also take out an a squared. So this will be b squared over a squared minus 1 over 4. Sorry, a squared. So this is a over 4, root 4, root a squared, root b squared over a squared minus 1 over 4. So root 4 is 2. 2 over 4 is a half. So it's a over 2. But square root a squared? A by a squared. So it's a squared over 2 root b squared over a squared minus 1 over 4. Yeah. So it is the same.
Why would you want it that form though? Should we memorize?
Because I'm a jerk, that's why.
The earlier
Yeah.
one was easy.
I'm making you work, that's why. Think of how much you've now learned by seeing this.
Yeah. Will they ask us in the exam to prove like this?
In semester 2, maybe. Yeah, it's like trigonometric proofs. Yeah.
Number 9.
9. Yeah. 9 is nice, isn't it? Yeah. Number 9 next. I think a lot of people who did this question probably got this. Yeah. Yes, you're half right. Okay. Can I scroll down? Oh, sorry.
Yeah.
Okay. The sides of a right angled triangle are in arithmetic progression. So that means this side is A, this side is A plus D, and this side is A plus 2D. Oh, good. The smallest side is 3. So this is 3 plus D, 3 plus 2D. And the area is 6. And you know it's a right angled triangle. So you know that that's a 90 there. What is the missing side? Okay, so look. Because the area is 6, you can say a half the base by the height should equal 6. So 3 goes into 6 twice, and you can bring up the 2, so it's 3 plus D equals 4, so D equals 1. So the sides are 3, 4 and 5.
That's simple.
That's simple.
Wait, I meant like cosine of 70.
How is 3 plus D the height?
I say the sides are in arithmetic progression. Painful, huh?
That's right, it is sine of cosine.
Can we do number
Pythagoras law.
Yeah.
as well?
Which one?
11.
11. Oh yeah,
I
11 is
managed to
good.
do it with the. I think I messed up.
You don't believe in yourself. Yeah.
But it
Because,
works in other ways, right?
Because you get 2 values of A, and then how would you know if you have 2 values of A?
Good, okay, let's have a look. Right, 11, is it?
Yeah.
Both the area and the perimeter of a right angled triangle is 30. What's the 3 sides? Okay. So you have a right angled triangle. It has 3 sides, obviously. A, B and C. And there's a couple of things you know about it. You know that the area and the perimeter are the same. So you know that A plus B plus C is the perimeter, is 30. You know the area is a half the base by the height. That's also 30. And you also know that A squared plus B squared equals C squared.
You can change the area to 60. A times B.
Yeah, that might be a little bit easier to do. So you can say A plus B plus C equals 30. AB equals 60. A squared plus B squared equals C squared. Now, we'll have to do some careful thinking on how to solve this. We can't just jump in. So, it's nice, if you get the A, then you can know the B, and then you can instantly know the C. So maybe I want to get the A first, which means I should try and cancel out the B. So, how will I do that? I could combine these two and combine these two in such a way as to cancel the B. So what I can do is I'll change these two into A plus B plus C equals 30 and B equals 60 over A. And then I can combine these two into B equals 60 over A and A squared plus B squared equals C squared. So these two and these two now. So I'll sub the B into the first one. So I get A plus 60 over A plus C equals 30. And I'll do the same thing here. I'll get A squared plus B squared, which is that now, 60 over A squared, equals C squared. Right, now remember, I'm trying to get the A. So what will I do next?
Equate.
Yeah, equate for which one? C. Yeah. Now, right, so I'll scroll down here. So in the first equation you can say C equals 30 minus A minus 60 over A. And in the second equation you have C squared equals A squared plus 3600 over A squared. Oh my goodness. Okay, so I can put this one into that one.
It's easier to find C first.
No, you tell me. Oh, it's too late now. I've committed to this path now and I have to continue. Right, so I know, it sucks. Right, 30 minus A minus 60 over A squared equals A squared plus 3600 over A squared. Right. Are we ready to expand this? So it's 30 minus A minus 60 over A times 30 minus A minus 60 over A equals A squared plus 3600 over A squared. 30 by 30 is 900. 30 by A is 30A. 30 by 60, what's that? Minus 100, that's an A. Now I don't want my handwriting to mess me up. A. 30 by 60 is 1800, is it?
Yeah.
Over A. Right. Minus 30A plus A squared. Minus A by that's 60. I need to go on to the next line, I'm afraid. Minus 180 over A plus 60 plus 3600 over A squared equals A squared plus 3600 over A squared. That's one line.
Yeah.
Now the good news, and there is good news, is that cancels that. And that one. So let's clean this guy up. 960 and 60, what's that, 1020? So I've taken care of that, and that.
10,000 is enough. 10,000.
You've done something.
I added in an extra zero.
No, that's an extra one.
1020.
Yeah.
Thank you. Right. Minus 30A is minus 60A. Any more?
No.
No. What's left? Minus 1800 over A minus... Is that 1800 or 180? How did I get that one? No, that's right, isn't it? Because it was 30 by 60, so there's two zeros. Yeah, okay. And how did I get that one? That maybe is wrong. That's the third last one, isn't it? That's wrong, yeah, sorry, that should have had two zeros. Yeah, no, something felt wrong. Right, so if I put together this one and this one, I get minus 3600 over A should equal 0. You can divide everything by 60, can't you? What's 1020 divided by 60? Don't tell me you can't divide it by 60, it will break my heart. What is it?
17.
Thank you. 17 minus A, and this one divided by 60, is it 60?
Yeah, so
Right, what should I do next?
multiply by
17A minus A squared minus 60 equals 0. So A squared minus 17A plus 60 equals 0. If you take everything to the right. It does have factors 30,
12 and 5.
Minus
12 and 5.
12, which is which?
minus 5.
Minus 5,
Minus 12.
Yeah.
yeah. So you are correct, you get two answers here.
Yeah.
Well, hold on. So let's look at the first case. So the first one here is 5. Now if we go back to this equation, we can get the B. It's 60 over A. So 60 over 5 is 12. And from Pythagoras, 13.
You don't need to use Pythagoras, you can use the AB equal, AB.
I know, but just let me use Pythagoras. Okay, so here, if this is 12, then you will get this side here as 5. And from Pythagoras, this is 13. So there actually is only one answer. It's the same. Yeah. Well, but I mean, my question was, what are the three sides? And the three sides are 5, 12, and 13, regardless. So it's a 5, 12, 13 triangle. Good grief. Okay. Who asked me this one? It was you, wasn't it? Yeah. Well, I'm only myself to blame. Like, I made the questions, so. What time are we at? Goodness sake, we've run over a good bit, haven't we? Alright. So where's everybody else then? Shouldn't they be like charging into the room?
Sure, what about questions for this?
I'm sorry, we're way over. We can do it next week, okay?
Like, we didn't do number, these types of questions.
Which ones? What page?
3A.
What page?
Page 62.
62.
Yeah, we didn't do like a type of question for 3A.
I know. I left that for you to try and figure out yourself as a hard one.